Today we're going to be working with compositions of functions, and in order to do that, we're going to start with that function notation students struggle with. So we are given three tables here, and each one is labeled f of x, g of x, and h of x. Remember that notation is just like y. It is the value that is dependent on the x. So this is my input, this is my output value. So if I'm looking for f of 2, I am saying the input is 2. In the f function, what is the y value or the output? So I go to my input here of 2 and my output is 4. So this would be equal to 4. For g of 4, it's telling me my input is 4 in the g function. So I would use the g function, which is the second table, go to 4, and my output value is 19. And then for the third one, h of 1, my input is 1 in the h function, so I go to the 1 and my output is -2. That's how we use that function notation. Now, it tells us, what if you took the output of f of 2 and used that as the input of g of x? Could you find the new output? That looks like this. That's what a composition of functions is. So 2 is the input for f, and the value of all of that will be the input for g. So we go to our f of 2, and we already found that was 4. So this would turn into g of 4 because f of 2 has a value of 4. And so then we go to our g function and find the input of 4, which we already have right here. So it is 19. The process is known as the composition of functions. You'll see that notation, both of these notations mean the same thing. That open circle there stands for composed of, so f composed of g of x. You'll also see it in this notation where the g of x is inside of the f. In both cases, you are substituting the x with that other function. So we're going to look at some more examples of that. It tells us here, given the function table and g of x is equal to x squared plus 3x minus 7. And we want to find g of f of 3. I'm going to write it the other way. I think it's easier to see the other way. But on the SATs and ACTs, you'll see this notation quite a bit. So g of f of 3. 3 is my input for f. So I'm going to go to 3, and the value there is 5. So this becomes g of 5. Now to find g of 5, it tells me this is the function for g. So I'm going to use this function. This is my input, so I'm going to replace each one of these x's with 5. So we get 5 squared plus 3 times 5 minus 7. Take a look at that. I didn't leave the x, I substituted the x. So the x is no longer there. I did not change that square because we are only substituting the x. So we remove the x, we substitute it with a 5, everything else stays the same. And then we can simplify this function. 5 squared is 25, 3 times 5 is 15, minus the 7. When we finish that, 25 plus 15 gives us 40, minus a 7 gives us 33. So g of 5 is 33, or g of f of 3. We're going to try another one here. It says find f of g of 2. So in this case, my g function is on the inside, and 2 is what I'm going to put into the x. So I'm going to replace the g of 2 by placing a 2 in the x values here. So I get 2 squared plus 3 times 2 minus 7. I have substituted each one of those x values with a 2. I haven't touched my f yet, so I'm going to leave that on the outside there. 2 squared is 4. 3 times 2 is 6. And then when we finish up here, 4 plus 6 is 10, minus 7 is 3. So now we found the value of g of 2. To finish this, we need to find the value of f of 3. So my input is now 3. I'm using my f of x table here, and 3 is 5 there. So f of g of 2 would be 5. So there's another example of a composition. Now we're going to move it to something a little bit different where we're not giving you the actual value of x so that you can see how to do that with two equations. So here we go. Given h of x is equal to 4x plus 5 and j of x is equal to negative x plus 1. And we want to find h of j of x. So h of j of x. So x is going to be my input for j, and that entire thing is going to be my input for h. I'm going to go ahead and do it in pieces here anyway so that you can see it as well. So j of x is negative x plus 1. So I've substituted this j of x with the value of j of x. Now, this is now my new input for h. So I'm going to come to the h equation, and instead of having x as the input, I'm going to have negative x plus 1. Again, we substitute. So that's going to be 4. My new x is going to be negative x plus 1, and then plus 5 at the end. The only thing I have changed here is just the x. And notice it's not still here. I'm not going to leave the x right here. We see a lot of students do that, and that's a big mistake, is leaving that x there. No, you have substituted, which means the x goes away, and this becomes my new x. Now we distribute, and we get negative 4x plus 4 plus 5, and I combine my like terms, and I get negative 4x plus 9. That is h of j of x. All right, the next one we're going to try is j of h of x. So this is very similar, except we're plugging the h of x equation into the j equation. So I'm going to take this h of x right here, and I'm going to plug it into this one. And we'll go step by step on that one again. So j of h of x, my h of x equation is 4x plus 5. So that's the one that's going to go on the inside. And now over here in my j equation, I'm going to substitute that x with my value of 4x plus 5. So I get negative 4x plus 5 and then plus 1 at the end. I have replaced that x. Everything else in this equation stayed the same. So the negative is still in the front and the plus 1 is still at the end. So this is negative, my new x plus 1. I distribute the negative and I get negative 4x minus 5 plus 1. And I combine my like terms and we get negative 4x minus 4. That is j of h of x. Notice that they're not the same. That's important to know. They're not commutative. So h of j of x does not have to be the same as j of h of x. All right. For this next one, C here, it says h of x. And that makes it kind of strange because it's got the same function, but that's okay. That just means that we're replacing it into the same exact equation. So we've got 4x plus 5 is the value of this h of x. So I replaced the first h of x with 4x plus 5. Now h is still the one on the outside. So I'm going to use this equation again. Again, the only thing I substitute is that x. So we get 4 times 4x plus 5 at the end. And now we simplify by distributing. 4 times 4x gives us 16x. 4 times 5 gives us 20 plus our 5. And so we get 16x plus 25. And that is h of x. All right, we're going to look at one more that is a little bit hard to simplify just so that you can see some more of this. So we've got h of x defined right here and g of x defined here. And we want to find h of g of x. So we are plugging the g of x equation into the h equation. I'm going to go ahead and do the entire part, skipping this initial part so that you can see how it's usually done. So h of x is the one on the outside here. And so it is x squared, and my new x is this g of x. So I get x minus 1 squared plus 5. I have taken this entire thing and plugged it in for the x. Now, to simplify this, the reason why I wanted to show you this, x minus 1 squared is usually a mistake students make. They want to square the x and square the negative 1. But remember, you've got to FOIL that or use the box. That's x minus 1 times x minus 1. So I'll just write this out here in another color. That is x minus 1 times x minus 1. So don't mess that up because then you'll miss that middle piece. So when we FOIL x minus 1 squared, we get x squared minus 2x plus 1 plus the 5. You will miss out on this middle term if you don't FOIL that out. Now we combine our like terms. So 1 plus 5 is 6. And so this would be h of g of x. I'll let you go ahead and pause there and try these two equations here and see if you can get those done, and then check your work. So pause your video, get those done. Those were a little bit easier, but it gave you the opportunity to try plugging an equation into the other for this compositions. So check those out. Make sure you got those correct. All right, now we're going to look at it from a graph point of view. So in this case here, we do have two different graphs. One of them is labeled f of x, which is this top one. The other one is labeled g of x. That's the reason why we use that function notation. If we just used y, then you wouldn't know which one we were talking about if we say, look at the y value, because there's two different functions here. So f of x, g of x, h of x allows you to label more than one function at a time. With the graph, it is very similar than the equation. If we are looking for f of 4, my input is 4. So I'm going to go to 4 on the x, and I'm going to find where my f of x function is. Well, that's right there. The f of x is at 0. My y value there is 0. If I was looking for g of -3, I would go to -3 on my x, and my g function is this bottom one here, and it is at -1. To do the compositions, we start again from the inside and work out. So -3 is what I'm going to start with, which we already know what g of -3 is. It's -1 because we just found that one. And so we get f of -1. Because g of -3 has a value of -1, I can substitute that whole thing with -1. Now I'm looking for where f is when x is -1. So I go to -1 and my f function is at 4. With a graph, it's pretty easy, or easier than with the equation because you can see where that value is. Here's another one, g of f of -2. I start from the inside. And so we're looking for f of -2. So I go to -2 and my f value is at 2. Then I'm going to g of 2. So I'm going to go to 2 and my g function is at -4. You can do it with the same function, just like we did with the equation. So f of -1, I start from the inside. And so f of -1, I go to -1 and my f function is at 4. So that becomes the new input. Now I'm going to go to 4 on my x and find what f is. And right there it is 0. So this would be 0. Go down here. F of g of 0. G of 0, I go to 0. My g function's at -4. Now I go to -4. And my f function is at 2. All right, for this last one's a little bit trickier just because it's giving us an equation and it's having us use the graph as well. So we would start from the inside and it says the input for f is -7. So I'm going to start with the graph since f is one of the graphs. And so I get h of, I come to -7 and my f function right there is at 7. So I've replaced this f of -7 with our 7. Now we're going to use the equation for the rest of it because h is defined by this function. So we would plug in a 7 for this one right here. So we get the square root of 7 plus 2, which is the square root of 9, which is 3. So h of f of -7 is 3. So there is your compositions of functions lesson.